Great honor to introduce this panelist speaking in the Boundary Spanning Opportunities panel this morning. The three panelists presenting today are leading authorities in their field of study and will use their research and experience to offer a broad perspective on the field of socio-environmental systems under stress, in transition, and design. The last speaker to present this morning is Dr. Joan Nassauer. Dr. Nassauer is a professor of landscape architecture at the University of Michigan. She is also co-editor-in-chief for landscape and urban planning, and she was one of the original founders of Succinct.
Good morning, everyone. I'm particularly happy to be here today because I'm particularly happy that among the boundary spanning approaches that the leaders of Succinct have chosen to include in the symposium is design. I am an ecological designer and a landscape scientist, and what that means in particular is that I make proposals working with colleagues who are ecologists and engineers. I make proposals for how we might intervene in the landscape, and then working with others from many disciplines, including various forms of ecology and engineering. I participate in the social science to assess how these interventions might work, how they might affect people and the environment. And so in this talk I'll give today about design, I'm going to focus on this word that's integral to Succinct and its mission, actionable. How design as process and product can contribute to actionable socio-environmental science. In the course of the symposium, you're going to have the opportunity to hear and see in the poster session many papers, many projects that use design. As I looked at the abstracts, what struck me, and I'll learn as the symposium goes on, what struck me is that many of those projects that employ design that will be presented here focus on design as process. And so in this presentation, I want to address design as process, but I really want to challenge everyone, whether your work explicitly employs design or not, to think about the idea of design products and how design products, the things we can produce together, might advance socio-environmental science. What you're seeing here, I'll get to again at the end of my talk. This is a street where I work in the city of Detroit as it looked in August of 2014 after one of the 200-year storms we've had in the last 4 years. And it is obviously not the product of design, but it demonstrates the power of product, of a tangible thing that we can all, scientists, decision makers, stakeholders, see and experience as a means to provoke action that we can all move forward together on. Everyone in Detroit now knows that Detroit has a terrible problem with flooding, not only in the streets and in the freeways, but in everyone's basements, almost everyone's basements. And that's partly because there's broken infrastructure all over the city. Everyone knows that Detroit has a problem with vacancy. More than 40% of the city is now publicly owned, and much of that vacant land or abandoned buildings. And so these shared experiences of the tangible help us move forward toward action, and the opportunity for us as scientists is to make that actionable part of our how we contribute as we conduct actionable socio-environmental science. I think it was actually just last week or so that the climate scientist Katherine Hayhoe published a short editorial in which she was urging all of us as we advance action toward addressing climate change to look beyond only more facts and only more data. She said that changing minds also requires providing practical, viable, and attractive solutions that someone can get excited about. And while she was talking about sort of relatable aspects of her own life, I want to use her words to help us think about how the possibility of producing tangible products that are relatable can help advance the impact of our work. So that, for example, in the project I'll tell you about more shortly, we built these 4 pilot sites on streets like this one. This is one of them. And so this tangible change in the everyday environment of people in Detroit is what is helping us advance the science that has multifunctional dimensions, very much including effects on water quality and human health. So now I'm going to spend a little time on the underlying theory related to these tangible products. And these are all, at least most of these relate to papers I've published in the past, and you can go read them if you'd like. I just want to touch on some of the key ideas here. A group of colleagues and I spent a few years thinking about what aesthetics has to do with ecology. And the answer that we offered in this 2007 essay was what these things have to do with each other, or maybe to address the kind of nomenclature of the moment, what does cultural ecosystem services? How do we articulate cultural ecosystem services? One way might be to think about what we all share in our everyday environment, that is what we dub the perceptible realm, the landscape. Did anyone, as you were coming to the symposium, wherever you were coming from, fail to notice the rain outside yesterday? Did anyone fail to observe the change as you came into the city of Annapolis from wherever you were coming from? This is really ordinary, everyday stuff, the way we observe the landscape. And we make inferences from it about the larger global environmental phenomena, or very micro-scale environmental phenomena, which we had in the top of the diagram. And the idea of this diagram is to show that landscape patterns are sort of the tip of the iceberg, if you will. They hold all of these other environmental phenomena, from global scales to micro scales. But our experience of them is what leads to our actions to change landscapes and ultimately to change environmental phenomena more broadly. So let's work with that perceptible realm. How do we work with that perceptible realm? This diagram from a couple of papers where I've developed this idea of the cultural sustainability cycle implies that if we put landscape, this perceptible realm, the landscape, in the middle and begin to use it strategically, we will make intentional landscape changes. We will design products, stuff, in a way that reflects people's cultural values, therefore is accessible, tangible. It reflects their cultural norms, but if we're the designers, it also is aligned with, and the key word here is aligned. It's not the same as, it is aligned with the underlying environmental functions that we aim to protect, the ecosystem functions we aim to protect, and the ecosystem services and their effects that we'd like to sustain. So the idea is to use the way we work, human beings, culturally, and giving us what we think we want in a package that also aligns with environmental benefits. And that's called design, to put those two things together in the same product. I want to juxtapose this diagram with a couple of things that the profoundly influential thinker and engineer Herbert Simon said in his seminal work, The Science of Design. I wonder if many of us here in the work that we're going to be talking about are putting our work in the framework of the science of design, which Simon described as really sort of an augmented rational process. His interest was in expounding on the process of coming up with ideas and testing them in a rational way. But even in that early essay on the science of design, he does nod to other things going on, and I've just excerpted a few of his observations here. Even then, he said, a deeper understanding of how representations, think of those as products, of how representations are created and how they contribute to the solution of problems will become an essential component in the future theory of design. And I love this. If you think about the power of cultural values and norms, Simon said, people may be relatively simple, but most of the complexity of their behavior may be drawn from their environment and their search for good designs. What I want to add to Simon's observation there is that our search for good designs is not rational. It's reflexive. It's intuitive. We know what we like. And if we are good ecological designers, then we align what we think we like with what might actually deliver environmental benefits. And to do that, we might use a process that I think one of the greatest ecological designers, a 20th century designer, John Lyle, described in what has always been for me a very, very influential essay on what he dubbed the alternating current of design process. In this diagram from his 1985 paper, it focuses on his key idea, which is that design, the development of design, is both rational and intuitive. Proposing an idea, having an idea, the light bulb going off, even I would say the synthesis occurring is a propose. Evaluating the idea, assessing the idea, thinking about how it works is the dispose, but it's an alternating current. And to design, you need both things. In order to dispose, in order to assess, you need a product. You need something to assess. But in order to have the idea, you simply need to have what has sometimes been described as a prepared mind. You need to have thought about the science, but the idea doesn't necessarily come directly from the science. Science will not necessarily give you the idea. And so Paul Upton and I took, in part, Lyle's conception of the alternating current and used it to link science with society more broadly in landscape change in this paper, where we were not talking about the science of design. We were talking about design in science, design products and processes in science. And in the context of landscape ecology in particular, where both he and I work, we were trying to make the point that landscape patterns do not always just occur, they are made. And sometimes they can be made in order to produce environmental benefits. The idea in this diagram is simply to say that a design product at the center can be assessed by social and environmental science and theories built that way. And at the same time, when we are working to co-produce research questions, and those research questions are embedded in those designs, those very same things are on some level tested and assessed by society as part of landscape change. Catherine Fu and colleagues just published a paper in Landscape Ecology in which they examine and expand upon the landscape change side of this diagram as a form of governance. And they develop the hierarchies of governance that are implied by that right-hand side of the diagram. If you think of it, this is a diagram of what we really did in one of the projects I'm going to show you at the agricultural project. If you think of this iterative loop, this propose, dispose, or what we called portray, compare in this large interdisciplinary project to develop new forms of agricultural landscapes, you might think of it this way. You start out with a small object, a small product, a kind of seed. That's on the left-hand side of the diagram. And you get the largest possible group to respond to that. You get lots of ideas from lots of people. That builds the idea. The idea gets bigger. The product gets bigger. It's more filled with information and knowledge, local knowledge and science knowledge. And then you have a smaller group dispose of that, develop the idea further, until on the right-hand side of the diagram, the object, the product, is as loaded with information as the group is. And that leads you to having a product that you're more confident to bring out into society. It's a propose, dispose series of both asserting products that have an intuitive dimension and critiquing and assessing their potential social environmental performance. So from this, I suggest that there are 4 key characteristics of design for actionable socio-environmental science. A process, certainly, and products that establish a tangible common experience. Very importantly, highly engaged experts who are interested in learning from others outside their own discipline. Margaret referred to this earlier. Products, these products are not just any old designs, and they certainly aren't whimsical or arbitrary. They are products that embody testable socio-environmental hypotheses. And then an iterative process that involves experts and stakeholders in ways that are appropriate to their distinctive experiences and interests, and that builds trust among everyone as we propose and dispose these products. So a couple of examples that I'll just touch on. This one was a project to look at how the Corn Belt could change forms of agriculture in order to reduce hypoxia of the Gulf, and also to look at what the social effects of changes in the structure of agriculture in the Midwest might be. And so first of all was the idea of working at a scale to produce a tangible common that addressed a tangible common experience. So rather than working at the scale of the Mississippi River Basin, we worked at the scale of these 2 much smaller representative watersheds in the area that was contributing most highly to the flow of nutrients to the Gulf. And we discuss it and describe the integrated assessment in this book. What I want to emphasize here related to those 4 criteria is that we did have a set of highly engaged experts who were interested in learning from disciplines very different from their own. They were both policyholders and scientists, and ultimately we consulted local people, the local farmers, so that we not only did we develop these scenarios together, these 3 different scenarios, and assess their performance in ecological models, economic models, and social models. Our social models were derived from our interviews with farmers who, interestingly, as a side note, found that their preferences for the future of Iowa lined up precisely with the phenomena that did embody the greatest environmental benefits from the standpoint of water quality and biodiversity. What about the actionability part of this? Well, we left this work having proposed and assessed these scenarios, but colleagues at Iowa State University and Iowa State University scientists who came after we collaborated with colleagues there developed a project called STRIPS. And they've actually built they've built tests that employed this idea of perennial strip intercropping that we developed in our project. They've demonstrated that it works to improve biodiversity and water quality. And now they have a project where they're employing on-farm research across Iowa in their STRIPS project, here led by Lisa Schulte-Moore. And so this idea was sufficiently plausible that it has been put into action. What about Detroit, the Detroit example? In the Detroit example, the key boundary object I described at the beginning, which was a problem that everyone recognized. It is a Great Lakes problem of water quality, particularly in Lake Erie and further downstream, but it's experienced by people in Detroit as flooding. It is a problem of vacancy, and abandoned buildings, as you see in the middle, but it is a problem that's distributed all over the city of Detroit, as you see at the map in the lower part of the screen. It is a problem that we knew we could address best in co-defining solutions, working across the disciplines, research disciplines that you see at the bottom of the screen. My colleagues are in all of these disciplines in 3 universities in the area. But very importantly, this map you see at the top, all those different colors are very distinctly defined neighborhoods in the city of Detroit. More important than our academic disciplines, I think, or our academic credentials, that, as shown at the bottom of the screen, was that collectively, we had worked in nearly all of those neighborhoods in the city of Detroit previously. Collectively, we had a track record of staying engaged with people in the neighborhoods in a way that was responsive to the situation as they saw it. So our partners in doing this work were the 2 on-the-ground community groups where we built our pilots, the Cody Rouge Community Action Alliance and the Warrendale Community Organization. Our project is called New GI, related to neighborhood and environment and water for new forms of green infrastructure. And very, very importantly, and I think this is the thing I'm most proud of with this boundary object we created, the design product. Our design product, as an idea, challenged 2 very different departments of the city of Detroit. The building authority, the Detroit Land Bank Authority that held vacant properties, and the Detroit Water and Sewerage Department, which needed to solve the problem of inadequate control of CSOs to the Detroit River and ultimately the Great Lakes. So we needed to work on the ground. The boundary object I'll show you there in the lower right was the idea that in the clay soils of Detroit, where the vacant properties needed to be, where the abandoned houses needed to be demolished, the basement holes would make an excellent place to store storm water, but make it look on the surface like a garden. These things were aligned. People in the neighborhood wanted a garden. What we really needed to accomplish environmentally was to hold and clean storm water. Mm-hmm. This doesn't look like a wetland. It doesn't look like a retention pond. It looks and acts like a garden. It was so important that we work iteratively through this process of designing and implementing the boundary object. So we needed to find a place where the Water and Sewerage Department was under an agreement with the state DEQ in response to a federal consent decree where they needed to address water quality, the Rouge River watershed there on the west. We needed to find places where we knew demographically we were controlling for population variation when we interviewed all of the households within 800 feet of the pilot sites. We needed to find pilot sites that were owned by the Land Bank Authority and where the Water and Sewer Department could see opportunities in this very flat landscape to move a lot of water. 300,000 gallons is what each of these holds. And we worked very closely with Tetra Tech, DWSG's contractor, to design these special bioretention gardens so water quality could be monitored coming in and going out, so that we all could do the science we wanted to do in research questions that we co-defined with our colleagues. So if you look at the cutaway, each of these gardens is really embedded with these research questions about well-being in the neighborhood. How is well-being promoted? How might real estate values be promoted? And how is water quality affected by these gardens? Going upscale, we actually ultimately now have examined similar governance arrangements in 11 legacy cities in this country, because maintenance and longer-term governance relationships are going to be essential to the long-term success of this approach. And ultimately, this iterative process, moving from the left to the right, has built enough trust with our colleagues in city departments that we're taking what we've learned from these 4 small pilot sites that we've built and developing approaches to work at the sub-catchment scale. If you see Yan Cho Fong's poster outside later, you'll see how she's working to take what we've learned here and bring it up to the sub-catchment scale, where we hope that our work and expect our work will be built because we've built trust with our colleagues. In the end, I ask all of us working in the realm of socio-environmental actionable research to think of design as an iterative process, and a process that includes both room for intuitive elements and rational elements, and that produces tangible boundary objects. Might be a landscape in your project, it might be something entirely different, but a tangible thing that everyone, the scientists on your team, the people who will be affected by your ideas can see and examine and develop further together. And here I simply reiterate these characteristics of design that I suggest we think about when we employ design in actionable socio-environmental research. Thanks.